many people in the room have been working on network automation for the past 5 years? Okay, good bit of hands. How about for the past 10 years? All right, still got some players. 15 years. And 20 years. All right, I love it. I see you, my long-timers out there. So 2003 was my very first journey in network automation. It was also my very first startup, Prolexic Technologies, which was the first commercial DDoS mitigation provider. And the thing that I started with for automation was pushing blacklists out to our edge routers for blacklisting IP addresses for botnets. And it was a really simple stack of TCP dump, a mirror port, and a Perl script using NetSSH. And this eventually evolved into an entire control suite for the network that did everything from config management to BGP session management to changing OSPF path weights throughout the network to reroute traffic, and even managing our reverse proxy clusters. And I did this all in C, PHP, and Perl. And yes, I see some of those looks out there. So I know that that is not very sophisticated compared to a lot of the network automation stacks. But I was super proud of it at the time. And after we sold Prolexic in 2008, I decided to go off into the commercial world. And so on my second interview ever, I was interviewing with the VP of a major ISP. And he was asking me questions about how I would architect various things or about how I would solve problems. And I was giving him all these really slick answers about writing scripts and using automations. He's nodding along, and I'm thinking that I'm blowing this guy's mind. Well, at the end of the interview, he says to me, you know, all that automation stuff seems really nice, read cute, but I really just don't understand what it has to do with operating a network. So, needless to say, I didn't get a call back. And I ended up doing what everybody does who has a mismatched skill set. I went into security. And I love that quote because it pretty neatly summarizes the state of automation at that time. So if we fast forward into 2024, today, if you step outside of networking in pretty much any enterprise IT shop, you'll see that all non-networking disciplines are really automated. Everything from HR to finance has a fancy SaaS application. It uses AI. I mean, you can even link together 20 SaaS applications with a couple button clicks and get something even better. So considering that myself and a lot of others in this room were working on network automation back in the early 2000s, we really have to ask the question, why haven't we seen full adoption of network automation yet? There's 3 primary factors influencing network automation adoption, and that's history, ecosystem, and perception. Because everybody knows that technology is the easier part. It's the human parts, the cultural parts, the money parts. These tend to be the difficult things. Oh, and you may have noticed over here this innocuous pile of bags. So these are actually limited edition bags, and during the perception portion of my talk, I'm going to be asking questions that are hopefully going to help challenge your perception of events. And those who answer correctly, which anyone can answer, get one of these limited edition bags. You can only get them during this talk. And my lovely assistant, Chris, here will be handing them out. Okay, so let's go into history here. There we go. History was my very least favorite subject in school, and I don't even feel particularly well suited to give a talk in it. So when I first started this, I asked Gemini, why is history so important to the present? And Gemini said, history influences the present by providing context and understanding for current events, shaping societal norms, cultural practices, and identities, allowing us to learn from past successes and failures, and enabling us to identify patterns and trends that can help solve contemporary problems. Essentially, by studying the past, we gain deeper insight into the reasons behind the world we live in today. I think Gemini was pretty spot on with that answer, and it's a much more eloquent way of saying that in order to know where we're going, we must understand where we've been. So when we talk about the past of network automation, who and what are we talking about? We're primarily talking about telecom, DARPA projects, and early hardware manufacturers, predominantly Cisco. And so when we think of network today, we tend to think about ISPs. And there are about 2,900 of them in the US today. But stepping into looking at the KIDA list, which is all the ASs ranked by cone size, you'll see that 2 out of the top 10 networks in that list are not telecom providers. And if you go even further into the top 50, you'll see that there's only an additional 2 that aren't telecom providers or have their history in telecom. The history of telecom is complex and contradictory. It's full of irony. It's a tale of monopolies. It's a tale of anti-competitive behavior. It's also, conversely, the origin of open source and of revolutionary ideas that power a lot of what we see today. So if you go back past the 1980s, the history of telecom is the history of Bell Systems, because Bell System was a monopoly. It later became known as American Telephone and Telegraph, aka AT&T, and sometimes even as Ma Bell. And whether you call that system Bell Systems, AT&T, or Ma Bell, they dominated the North American telecom industry for over 100 years, from 1877 to 1983. And the thing is, they weren't just a geographic monopoly, they were also a vertical monopoly, meaning that they dominated multiple stages of the supply chain. And as a monopoly, Ma Bell engaged in a lot of anti-competitive behavior, such as price fixing, all among their supply chain, a lot of frequent mergers and acquisitions. A lot of times this was by any means necessary, and also providing financial punishment to their customers who dare step outside their supply chain. For example, if a customer wanted to use a non-AT&T telephone device, the customer would have to go buy it themselves, take it into AT&T for rewiring, pay for that rewiring service, and then also pay a monthly service charge on top of that for using a non-AT&T device. So, eventually this bad behavior led the government to step in and create the 1953 Consent Decree. And the Consent Decree also had this completely mind-blowing unintended consequence. Somehow the magical combination of US government regulation and AT&T lawyers managed to create open source software in the entire open source community as we know it today. Let's take a closer look at this timeline and exactly how this happened. So in 1949, is the right setup? Yes. So in 1949, the government stepped in and charged AT&T with anti-competitive behavior, filed a lawsuit against them. Well, Korean War broke out, a couple years went by. In 1953, they finally reached the Consent Decree. And this limited AT&T to 85% of the telecom market in North America. It also limited the products and services that they could sell to common carrier services only, and meant that they had to give away all of their patented information for free. So then in the 1960s, Bell Labs started working on a multi-user operating system for mainframes. DARPA was simultaneously funding the same project with a bunch of universities, including like UCLA, MIT, and UC Berkeley. Well, 1970, they weren't having much luck, so a few of the developers decided to go smaller with the project. And they created a really simple single-user operating system that we come to know as Unix. And so Unix spread pretty rapidly throughout Bell Labs. Everybody loved it. And like any user base, they drove the devs absolutely mad with tons of feature requests that led them to stay up tons of nights and weekends, writing hundreds of thousands of lines of code in a relatively short amount of time. That also included multi-user support. And by this time, too, Unix was about 75% hardware independent, meaning that most of the code base was not reliant on the hardware in which it ran. So then, in 1973, Unix was finally presented at a conference, and the whole entire world went absolutely bonkers for it. They got a ton of requests, mostly from universities and governments, for Unix. And remember, AT&T can't sell anything that isn't common carrier services. So AT&T lawyers wanted to stay out of the ear of the US government, told the main devs, Thomson and Ritchie, sure, go ahead, let's give it away for free. Users just have to pay for shipping and the cost of media that it's shipped on. So Thomson and Ritchie started shipping this out primarily to universities. And so it's this 10 years here from 1973 to 1983 that open source is truly born. It's when every computer science student, every science student that touches a computer in university learns that software is provided for free and you rely on a network of your peers for support for it. And you can also modify the source code however you see fit because it's yours. So then, 1983, AT&T gets in trouble with the government. Yet again, it's an antitrust lawsuit now. And AT&T is broken up into 8 regional Bell operating companies. Well, now what also happens is the 1953 consent decree no longer applies. So AT&T almost instantly starts charging for software. So now you have 10 years of university graduates who believe that software should be provided for free to be modified however they see fit and community supported, have that rug yanked out from under them. So just in 7 short years, Linux comes in to fill this void. And also, coincidentally, in 1991, this is when AT&T sells the rights to Unix to Novell. So this is when Unix begins its slide into obscurity, and Linux starts its rise to fame. So even though AT&T was pretty much in constant trouble with the government, they're also conversely responsible for a lot of the innovation that we see out there today. Literally, there's like hundreds of significant innovations that came out of Bell Labs. Some of the most notable, in addition to Unix, are the transistor, so what's responsible for all solid-state electronics that we have today. The whole concept of the cellular network, which the first one was deployed in Chicago in the 1970s. Solar cells, so the whole idea of converting light to energy. The laser, which at first was called the optical maser. I mean, really, could they have gone wrong naming that one? Also, the Telstar 1 satellite, so you could place now calls globally from anywhere in the world to anywhere else. The programming languages B, C, C++, and Snowball, which I really thought Snowball was going to be a precursor to COBOL, but it's not, so that was very disappointing. And also, radio astronomy that's being used to power the search for extraterrestrial life through the SETI project. And I feel like the history of Bell pretty much neatly summarizes the entire discipline of networking. It's one that's capable of altering the entire trajectory of humanity, but it yet is somehow strangely held back and strangled by its own baggage at times. So, while AT&T and the government were busy cooking up open source software, Cisco started creating networking equipment and also the greatest barrier to network automation that has ever existed. When we think of Cisco systems, we normally think of Silicon Valley. We think maybe of Stanford, where it started. We think of really forward-looking innovation. We don't tend to think of creating barriers. But the simple fact is that Cisco built their creative moat out of their customers. As part of the research for this talk, I went back and I talked to a lot of the people that worked at Bell Labs in the 70s and 80s, as well as people that worked at Google in the 90s. So I wouldn't just get the history as it came out of a book or read on the internet. I'd actually understand what people were thinking at the time and what they observed. And one of the quotes that stuck with me was, "The most impactful product Cisco ever released was certifications. They convinced an entire generation that the right way to do things was to type commands into a network device and to feel special because of it." And so this also meant that Cisco didn't build in any programmatic interfaces to their systems and no interoperability. Cisco literally defined the idea of systems as pets, highly complicated creatures that cost a fortune, cannot be dealt with at any sort of scale, and had to be dealt with only by specialty trained individuals. So, I would love to have time to go into the dark and twisting tunnels that are DARPA projects here. But the most important piece to note out of the history of DARPA is that it's responsible for ARPANET and subsequently TCP/IP, which is the foundation of the internet. And in addition to the internet, some of the other little things to come out of DARPA projects are GPS, supersonic flight, Boston Dynamics, so Big Dog and the robots that can do like backflips and dance moves and everything, brain-computer interfaces, and hundreds of more inventions. And that's only what we know about. So if you ever have like a piece of code that won't work or you're stuck troubleshooting, I highly suggest you go Google DARPA projects because your mind will be taken right off of whatever is bothering you. So the result of this whole setup coming into the early 1990s is that it's the perfect storm to accelerate the compute automation ecosystem and completely delay the network automation ecosystem. On the compute side, we have free open source operating systems. We also have an ecosystem of surrounding software that is open source and a community of people that's used to supporting this. On the network side, we have only closed, paid-for operating systems that are also intricately bound to their hardware. We have a very limited software ecosystem that's mostly vendor, and it's all vendor supported. So Google was the very first to break free of the tyranny of the CLI and create their own open platform and surrounding ecosystem. So Google had a really big problem. Hardware manufacturers, meaning Cisco, still thought of dealing with network devices like switches, one device at a time. And Google had incredible growth. They needed to deal with entire data centers full of switches, 10, 20, 30,000 at a time easily. So in 2006, Google moved to a homegrown switch and software platform, but they wouldn't even talk about it until 2015 because they considered it part of their competitive differentiation. In fact, every image on this slide is from the very first public Google talk on their network platform. It's really cool. I suggest you check it out sometime. So privately, from the people who actually worked on these projects, they say that Google had the exact perfect environment to make this happen. They had this immense environmental pressures for growth. They had access to capital. And most important, they had people to work on this that weren't necessarily network experts. So they approached it from really first principle thinking, well, if we have to deal with these things at scale, we're going to make everything programmatically accessible, and we're going to build an automation ecosystem around it from the very start. So when I first started this research, I definitely had some built-in biases. I thought telcos and monopolies equal bad and stagnant, and Silicon Valley tech is always good and progressive. And what I learned really changed the way that I think about things, and hopefully what you've seen here right now will help reshape some of your preconceived beliefs as well. So ecosystem, I've mentioned this ecosystem thing a few times now. And a tech ecosystem is a network of interconnected and established businesses, startups, suppliers, developers, customers, that all work together to innovate and support each other. More generically, the term is used to describe complex interactions between various parts of technology, infrastructure, people, and culture, usually within a specific context. So let's take a deeper look. What is it that makes automation take off in some cases and stall out in others? Ecosystems tend to build on themselves and keep building on themselves in this sort of flywheel effect once certain conditions are met. And this is nothing in particular to tech. In fact, this has pretty much been happening through all of human history. If we look at it, the agricultural revolution would probably be one of the first examples of this. We have this complete novel innovation of agriculture, switching from foraging, getting wild plants to growing plants purposefully. We have subsequent huge investment of people's time. Then we have automation put in around it, such as domesticating animals for farm labor, creating tools to make that labor easier, which then gives people even more free time to work on even more innovation surrounding it. And we see this exact same thing happening in technology today. If we look at the ecosystem flywheel applied to compute and software, we can see Linux as a major innovation, followed by venture capital investment into the surrounding tools around it. We see APIs come out that allows a ton of automation and interoperability between systems and different tools. And then we have ever-cheapening hardware driving this as well. So Linux is historically this huge driver of innovation because of a few things. The first one is that it's open source, right? So anyone can view, modify, distribute the source code, just like Unix taught everyone to do. And also, it's completely community supported, just like Unix, the US government, and everybody taught everyone to do. And so one of the key features here about open source is really the fact that it's free. So it lowers the barrier of innovation. Instead of just being money, it can also be knowledge, or it can be a combination of money and knowledge, which is even more powerful when you can put two resources behind developing things. And probably one of the greatest features about Linux is that it can run on a variety of devices and keeps being modified to run on a variety of devices. So it can run on anything from smartphones to IoT to embedded systems. In fact, if we look at it right now, it's starting its own flywheel effect with AI because NVIDIA's Linux is a distribution or is a variant of Ubuntu, and that's actually what's powering the new H200 systems that pretty much all of AI is running on now. And so how exactly did Linux give this major kick to the flywheel? And that was pretty much when it reached a critical mass. And Linux reached this critical mass in the 2005 to 2010 timeframe. This is when the market had a good variety of competition between various Linux distributions, which created wide adoption of Linux as the server platform of choice. And so what quickly followed that was a boom of investor capital that came in primarily to fund SaaS companies, because we had the perfect ecosystem now to build SaaS. And if you look at the top line there, that's the amount of investment in SaaS, and the bars represent the amount of startups in the SaaS world. And that's not an error on the graph. I actually had to remove some data points because of the macro conditions. There was such a massive influx of capital in like 2021 that it just made the whole graph look horrible. And then, of course, on top of this, we have Moore's Law coming into play, which Moore's Law says that the amount of transistors doubles on a chip approximately every 2 years with no significant increase in price. And so we get ever declining costs of compute and associated componentry like hard drives and memory. So I started this slide with this quest to visualize when it was that network operating systems reached any sort of critical mass, or if they had yet. And my whole hypothesis was that Linux was actually the network operating system we've all been waiting for. It just had to reach sufficient maturity to be considered that. And then the more things I started putting on this plot, I realized I'm not even sure that I know how to define a network operating system. So I went to the NaaS Slack, and we've pretty much coalesced around this definition now that an operating system is just an operating system. It's all dependent upon the context in which it's used. And so while I didn't find exactly what I was looking for on this slide, I don't think we've reached peak density yet. I think sometimes the value is in the journey, not necessarily in the result. So if network operating systems haven't reached this critical mass yet for VC investment to be interested, what has driven VC investment in telecom? And I was talking to a venture capitalist friend of mine, and he said one of the barriers around networking in general is that it's got this limited ecosystem of things that you can rely on, and the addressable market for various products tends to be pretty small for individual products. Like, you have to go bigger with it in order for it to hit more addressable market. So this rise that we see here in VC investment in telecom followed two very different things that changed VC perception about the networking industry. And that was the release of OpenFlow in 2012, and then the release of the OpenSwitch by Facebook as part of the Open Compute project in 2013. This gave the perception that all of a sudden there was much more of an open ecosystem to invest in around networking. So my main motivation for doing this slide and doing this bit of research was mostly that I just wanted an excuse to write an ML script. So I wrote a Python script that did sentiment analysis of all the publicly available repos on GitHub, and it looked at their descriptions in order to tell if they were related to network automation. And let me tell you, GitHub has a lot more data than you think it has. It's pretty incredible. So for example, how I did the training for this model is that the word network followed by the word automation is good. The word social followed by the word network is bad. I also used a lot of other keywords in the training as well. So do I think that the exact number is incredibly accurate on here? No, I think it could be with more training, but I think that the trend line is absolutely correct. And as a sanity check to this, I went and I asked GPT, Gemini, and Anthropic how many network automation repos were on GitHub. And GPT said thousands. Gemini said it didn't know, but it gave me a ton of helpful keywords to search by. Anthropic told me precisely 365 matched network automation. And so I also went to GitHub and I tried some of Gemini's helpful keywords, and pretty much all of those returned thousands of repos. So in 2024, there was $12.2 billion invested in food technology. This is compared to a $3.3 billion in telecom. This gives us a whopping 7,355 automated food service delivery platforms, and yet we still don't have network automation. So that disparity in investment is driven because there's a few more barriers to overcome with venture capital investments with networking than in software and compute. So types of investments have a hierarchy with different types of investors. At the top of the pyramid, requiring the smallest investment to get to a viable product is software. In the middle of the pyramid, we have hardware, which is really two separate categories. It's small components like semiconductors and memory that require less investment, and then complex things like routers and switches that require a lot more investment. And at the very bottom of the pyramid, we have infrastructure. So that's things like data centers, power plants, fiber, satellite. The top of the pyramid, so simple software and simple hardware, really align with venture capital investors. The bottom of the pyramid, complex hardware and infrastructure, matches with private equity, high net worth private individuals, or public companies that can fund the construction of things through public funds. So networking is kind of weird in the way that networking innovations can't always leverage other infrastructure. Like software is the thing that leverages existing network infrastructure as part of its development. But networking can't always do that. Sometimes you have to go and you have to build the complex hardware, or you have to build a piece of infrastructure as a part of your innovation in networking. And this just simply runs into problems that software investing doesn't have. So it turns out that who your investors are really does matter, and it produces vastly different outcomes. Venture capital and private equity have much different investor profiles, and these different profiles yield much different results. So in venture capital, and I actually have to look at this slide. In venture capital, they're looking to take a minority stake. Also, their primary form is equity. They also are looking at very immature companies, like they're looking at companies that don't necessarily have a product yet. And their risk tolerance is super high because they're placing a lot of bets on various different companies for very low dollar amounts, and they're only expecting a couple of those to pan out. And this means because they're placing a lot of bets, their risk tolerance tends to be super high. And because, again, it's a lot of companies, their operational involvement is really low. And then if you look at private equity, they really say they invest in anything, but certain funds tend to specialize in certain verticals. They're looking for a controlling interest, so greater than 51% interest. Their investment amounts are much larger. They're taking stock in the company in both equity and debt. They're looking at mature companies, so they want something that already has a track record of producing success. And their risk tolerance is very low because they're placing very low bets, they're placing very high money bets on not very many companies, so they're expecting just about all of their bets to return. And because of the fact that they are very risk intolerant and they own a controlling interest, their operational involvement is very high. They're also just not creating value through growth. They're creating it through mergers and acquisitions, through optimization, and through financial engineering. So I've talked about perception. I mentioned it before when we were talking about VC investments and how perception can change the way that investors invest. Well, human perception, that is our interpretation of the world, is shaped by so many things. It's how much information we get, what kind of information we get, the prior beliefs that we have, our biases, our culture, our expectations, and so many more things. And what often happens is that the more information we get about something, the more often we get it, the slower it seems to move. Whereas the less information we get about things, and the less frequently we get it, the faster things seem to move. So when I was in grade school, I used to go on road trips with this friend of mine, and her dad did this totally awesome thing where whenever we would ask him, are we there yet, he would tell us 5 more minutes. Didn't matter where we were or what had happened, it was always just 5 more minutes. And so because of that, it was always impossible to tell exactly where we were in the journey and how far we were from the intended destination. We had no idea because we were receiving the same information very frequently. And the same effect plays heavily into our perception of technological advancements. all the technology that we see today took much longer to evolve than is often appreciated, and when you're on the journey, it's nearly impossible to tell where you are. So this classic image that we're looking at is the classic bell curve, and it's a favorite of business schools and venture capitalists everywhere. This originated in the book Diffusion of Innovation by Everett Rogers. And Rogers created this model to explain how, why, and how quickly adoption of innovation spreads through a social system. So that cute little black square there that you see, that's called the chasm. And this is what all startups hope to cross in order to say that they're on their way to success. It's when you're moving from the daring group of early innovators that will basically try anything to the later group of early adopters who are a little bit more conservative. And once you cross this chasm, you're going to accelerate up that curve and reach full adoption. So, very first prize question here. What year was this book published?
98.
What year?
98.
Nope.
68. 83.
Well,
Which book? Crossing the Chasm or which one?
the diffusion of innovations.
1991. ISBN number?
So somebody was so close, but not yet.
62.
It was 62, the first 62 right there. Yes. You now are the owner of this lovely duffel bag. So that was a mind-blowing thing that I learned doing this, because the very first time I ever saw this bell curve was on a VC presentation, and to think that it was actually something that was done back in 1962 really shocked me. So I hear comments all the time that the network ecosystem lacks tools, that there's just too much old equipment out there, that why bother to automate something, we'll just keep doing it by hand. And the thing is, when you're really close to something, you get caught up in the nuance, and it's often impossible to tell how popular it is or how popular it will be. So this quote, "There's just not that many videos I want to watch." This was said by a CTO and co-founder because he wasn't sure that his company was going to make it. So next question is, what company is he talking about? You guys all got that one. That one was too easy. I heard. So who's the first person to say it? All right. You said there was like 3 people over here that were so close. Okay. So this was 2005, and Stephen Chen, CTO and co-founder of YouTube, said this while YouTube was literally serving up 2 million videos a day. They were getting close to their IPO, and they were only a year away from being acquired by Google for $1.65 billion. And so clearly, Stephen was in the middle of the chasm, and he had no idea where he was on the curve. And that's the thing, he was just way too close to the problem. And that's because, in reality, the chasm looks like this. It is not a cute little square. When you're really close to the innovation, you have no idea how big that chasm actually is. And you have no idea where you are on your journey to popularity and adoption. It always could just be literally 5 more minutes away. And this is because of a couple of factors, is that it's really difficult to assess things that don't have prior benchmarks, like video did back in 2005. And it also happens that success is really only claimed correctly in retrospect, and not really when you're on the journey to it. And so, oh man, did I miss a question? Good job. I want to make a, I know, now like which question did I miss? Well, now I'm going to have to throw one in.
You need to fill in the dead air right now.
I know, okay. Well, so I'm going to think of another one though for the end of this. So technology always moves at a much slower pace than it's perceived. When I was talking about, I was originally going to do a presentation for NAF that had to do with greenfield networks versus brownfield networks. And I was talking to a friend of mine about this, about why brownfield networks are so incredibly difficult. I said, why can't it be like self-driving cars that happened in like 15 years? There's nothing more brownfield than self-driving cars. You have roads that have been around since the start of humanity, and you also have cars that have been around for as long as telecom. Well, it turns out that if you look just really briefly into self-driving cars, it seems like the technology evolved overnight into the self-driving taxis that we see everywhere today. And so this is like Google, a Google project that turned into Waymo, and it was commercially launched in 2020. Except that, if you look at Waymo's Wikipedia, it actually started with the Stanford racing team participating in the DARPA Grand Challenge for self-driving capabilities. And that was in 2005, and the very first DARPA Grand Challenge was even in 2004. Except that isn't where it really started either. The machine learning used in self-driving cars and pretty much all AI traces back to research by John Hopfield. And Hopfield published his first paper in 1982 titled Neural Networks and Physical Systems with Emergent Collective Computational Abilities. And yes, here's my note for my next question. Where was Hopfield when he published this paper? Bell Labs was over there.
Planet Earth.
Planet Earth, also a great guess. And so this is yet another thing to come out of Bell Labs. And the thing is that, of course, this isn't really where it started either, because the quest for self-driving cars actually started with another DARPA project in pursuit of self-driving tanks back in 1966. Except that isn't even where it really started either. There were private companies and people looking into self-driving technologies as early as the 1930s. So the seeming overnight success of self-driving cars on a brownfield network actually took 54 years in the most generous interpretation. So if it's really difficult for us to tell where we are on the journey to network automation because we're deep within the chasm, what are additional signals that we can look at to tell us where we might be on the adoption curve? We've already seen really strong evidence that the amount of open source software is trending up and to the right in the network ecosystem. And we are right now at a conference on the topic of network automation. And from watching Slack, tickets were only slightly easier to get than a Taylor Swift concert. So network as a service is a term. Back in 2015, my third startup, PacketFabric, we were trying to think of what to call it because it was the idea of deploying network just like deploying compute on AWS. And some of us wanted to call it SDN. I thought we needed something that sounded more software-y, so I went with network as a service because I Googled it, I looked at the Google Trends, nobody was using it. Well, now that term is clearly going up and to the right with Google Trends. The next, are we on the right thing? Yeah. There we go. So the next measure of pretty much any topic is how much people are writing on it. And if we look at the amount of books published on Amazon on the topic of network automation, it is going up and to the right. And in true form to the constant irony and reversal of rules that is in and around networking, the very first book published on Amazon in 2016 on network automation was Programming and Automating Cisco Networks. Okay, so who can tell me what's the difference between C and C++? One. It's one. And why don't network engineers get that joke? Because they're bit operators. You're welcome for that. Anyone can use that one. Okay, so another long-running joke we had around PacketFabric was that we were just like Jurassic Park. We had all the problems of a major theme park and a major zoo. We had all the problems of a major software company and a major network company. And this raises the question, what exactly do network skills look like? Is there still a big distinct divide between network and software? And so in the spirit of open source, I decided to do a survey. I had a friend, Kat right there actually, send it out to the Nanog mailing list, specifically so I could avoid any bias by sending it to a network automation specific group. And I received, by the time I made these slides, I received a total of 80 responses. 5 had to be discarded, so 75 responses total. The first question asked was what operating systems everyone is using in daily activities. So I could look at what percentage of operating systems in use right now is open source. And the answer is that 13% of currently used operating systems in use are open source. Unfortunately, I wasn't quite clever enough to craft a question that would give us year-over-year sense of what this trend is. But I have a feeling if you go back 5 or even 10 years, this would be much closer to 0. So this graph represents two questions: the skill people most wanted to learn, and then also the skill people most dreaded to learn. And I thought that this was going to tell me what skills are hot, what skills are not. But as I looked at the answers, I realized that people dread learning some of these skills exactly because they're popular. So the only thing we really know is that the skills that are trending are Ansible, Go, Python, and Terraform. What's most interesting about this question is that 3 people answered with the same variation of a write-in question, which was some automated management capability without vendor lock-in. The next couple of questions were asked to determine exactly what certifications people are letting lapse versus which they are continuing on with. And my first question after looking at the data is maybe people are letting certificates lapse because they're going into management. And so I looked at that, and there was exactly 4 lapsed Juniper certificates that corresponded to a change in title to a management type title. And so who's losing certifications is Cisco, Juniper, VMware, and Checkpoint. There's a lot staying neutral. The only one that's gaining is Arista. And there's also a lot of negligible gains around Kubernetes, Red Hat, SonicWall. And what I think this really shows is the diversification in what we consider a network skill set. So anecdotally, we've probably all seen that job roles are evolving. And to quantify this, I asked what people's current job roles are versus what they wanted for job roles in the future. 68% of respondents had traditionally labeled job roles like software engineering, network architect, network engineering, site reliability engineering. And this was versus for only 47% who wanted traditional titles in the future. So this is a 20% shift towards more hybrid job roles. Currently, 5.6% of people are called network automation engineers versus 19.2% who want to be. So that's almost a 4 times increase in people who want to be in a network automation engineering role. This slide is also a mashup of 2 questions, which is what tools are you currently using versus what tools you've adopted in the last year. Tools are plotted on the x-axis versus for adoption in the last year, and on the y-axis for how many people are currently using them. There is also a little bit of change based on percentage and change between adopted and using, and some defuzzing so it could be readable. And what's really clear from this is that Python, Ansible, and NetBox are emerging in that upper right-hand quadrant there. And what I'm really curious about is who's using Bash and why is it gaining in popularity so much? Like seriously, if you're using Bash, come talk to me after this. I want to talk to you. So what we've seen today is that network automation has some great accelerators working for it. It also still has some barriers. On the accelerator side, we're seeing increasing adoption of open source software. In the community, we're also seeing increasing just number of open source software that's out there. And we're also seeing a lot of people who are closest to the problem learning crossover skill sets. And this is only going to further increase the amount of automation and innovation that we get out of the system. In the barriers, networking started as a highly manual thing, and that's been a really difficult hurdle to overcome. We're still overcoming it right now. And also, that I forgot the second point, but not a big deal. And so working on both sides of this is that we have the fact that right now we're in the middle of that adoption curve up to full adoption. And so it's just really difficult to tell where we are on that. But here's the thing. If we just keep driving and pushing on the flywheel where we can, we're going to get up the adoption curve and we're going to reach full adoption of network automation. So thank you very much for your time and attention today.